When you vote for someone, can you really tell with 100% surety that your ballot will be counted? Or how do you verify a person whom you recently met online is actually the person they pretend to be? To answer all these questions, you need a system that could store all your records and allow your facts to be verified by not 1 or 2 or 10 people but by everyone. This way, no one could cheat the system and edit any of your records because if they did, everyone would be watching. To put it simply, you would need a specialized system called blockchain. A blockchain is like a storehouse that stores all the transaction data and information electronically in the form of blocks. The idea behind blockchain is to record and distribute all the digital transactions and not allow anyone to edit them. To make things simple, consider blockchain like an account book in a warehouse that keeps track of first all the items coming in and out of it, 2. who sends or receives them, and 3. total money spent or gain in the entire transaction. So a blockchain is like an account book where all these transaction details are stored. The only difference is that no single bookkeeper records and verifies these transactions. Instead, each person on the network acts as a bookkeeper who tracks and records every transaction. And since there are many verifiers, if one verifier makes error, it would be immediately found out as the accounts won't match. And instead of an account book, all the data on the blockchain is stored as a digital ledger in blocks. So a blockchain network is nothing but made of these millions of blocks that keep records of each and every transaction within it. Now talking about blocks, remember that each block contains a set of data that typically includes first, the transaction details like who sent the money to whom. Second, hash. You can compare a hash with a biometric identification like a fingerprint that generates a unique set of numbers when we create our ID proofs. Similarly, a unique code of numbers called hash is generated each time new data is entered into a blockchain. And third and the last thing that the block stores is the previous block's hash. This means that the transaction details of any preceding block are stored in the new block and so on. This is because there is a limit to the amount of data a single block can store. Because of this, the process of linking one block to another goes on and on, forming a chain-like network of blocks linked together. This entire process of linking makes storing and tracking information very easy and secure. Because if you try to tamper with, let's say, the second block, this would also alter the hash of the second block. In turn, that will make the block number 3 and all the following blocks invalid because the blocks don't store a hash similar to the previous block and your transaction will be rejected. And that's just step number 1 of a multi-layered security system that makes blockchain extremely secure. Step 2. Step 2 involves a process called encryption. Encryption ensures that the records on the blockchain are stored in the form of a complex mathematical codes or numbers. Consider it like a unique identification number that you get when you create your tax identification number or TIN or any other ID proof. This means that only the owner of the record knows all his data and only he can use it to make transactions using a public-private key partnership. A public key is like the email ID that stores your digital address and everybody on the blockchain network uses it to identify you. And a private key is more like your password that only you know about and allows you to make transactions and protect your data. Now, encryption can surely give you a sense of security about your data. But with so many programmers and hackers out there in the world, there is always a slight chance that your data can still be tampered with. And blockchain eliminates this slightest of the possibility by using its third security parameter called decentralization. Now, when I say decentralization, the first thing to know is that blockchain transactions don't need any third-party intermediary like a bank for your transactions to go ahead. But from the security point of view, a decentralized or a distributed system means that there is no central place or authority that controls, tracks, and keeps record of your transactions. Instead, a copy of your transaction details are distributed to the entire network of people or computers within the blockchain network. These computers are called nodes. Every node has a copy of each and every transaction taking place within the blockchain, and each time a copy is updated, the node updates its records, making it impossible for a person to alter or tamper any records. To understand this, consider a network of more than 1,000 computers located in a single place that keeps records of the company's finances like its expenses, client's account details, employee details, etc. Now, what if a fire broke out in the building, burning out every computer, or an insider from the company suddenly tampered or erased all the database stored in those computers? Obviously, all the important data will be lost or corrupted. That is a problem with the centralized authority controlling transactions, or let alone anything. And that's where decentralization scores over centralization. Because a decentralized network like a blockchain spreads out copies of transaction data to millions of computers or nodes around the world. So if somebody tries to tamper with your data on the blockchain, his record would not match with all the other nodes existing within the network, and his transaction would be deemed invalid. The only way they can carry out a tampered transaction is by altering more than 51% of the copies existing within the entire network. Good luck doing that. Because of the size of the blockchain network these days, it is literally impossible to carry out such attacks without spending a lot of money, resources, and time on them. And even if they do plan such massive alteration, that would easily be noticed by other members on the blockchain, and they would easily switch to a new and safe version of the blockchain. Now, combining all that we have learned till now, let's see how blockchain transactions actually go through. In the step 1, you enter the transaction details like the receiver's wallet address and the amount of Bitcoin you want to send to them. Remember, all these details are secured using the hashing algorithm. Next, a copy of your transaction details encrypted as hash gets distributed to the entire network of people in the blockchain. Now, these networks of computers or people called miners try to figure out the right hash value by solving some really complex mathematical equations called proof of work. Once a miner solves these puzzles by generating a hash similar to your transaction is confirmed as legitimate and the new block is created. And this entire process of validating a transaction and adding a new block to the blockchain is called mining. Each time miners validate a transaction, they get rewarded with some gifts. Like Bitcoin miners get some Bitcoin for every approved transaction. Finally, the new block is added to the chain of many more blocks existing within the network. This chain of blocks is nothing but a long history of every transaction that has already taken place in the blockchain. Congratulations, your transaction is complete, and so is our video. But before leaving, I have a question for you. Comment and tell us which hashing algorithm does the Bitcoin use. And don't forget to hit that subscribe button and vote a thumbs up for this video. And stay tuned to our channel for more such videos.